We're from Standard Bank Corporate Investment Banking. My name is Godlonton. I'm a software developer from eMarket's pricing and risk team at Standard Bank Corporate Investment Banking. I'm joined today by Justin Pike, also a software developer and team lead of what we call the single dealer platform, eMarket's Standard Bank Corporate Investment Banking. We're proud to be here today and be a part of the Java conference, and we'd just like to share with you guys a little bit about how we use Java to build what we call a foreign exchange trading platform. So without further ado, we're going to start off with a brief demo. There we go, that's better. We'll start off with a brief demo of our eMarket Trader platform, which is one of our client-facing channels that allows our corporate clients to place foreign exchange deals. So Justin, if you don't mind logging in. Just switch screens. Yes, we don't have a great resolution here, but this will do. So a typical use case for one of our corporate clients, we have a client in the South African agricultural industry that purchases equipment from the US, and let's say for argument's sake they're looking to buy a new tractor with a $10,000 price tag. They book the deal, or they place the order today, and the moment they place that order they're exposed to foreign exchange risk. So if the payment terms on the purchase is cash in full within 1 month, from the time they place that order, they have to now settle that deal in US dollars. But of course, they operate in rands. So what do? Well, they come to eMarket Trader, and they have the option of booking a 1-month forward contract and essentially converting that rand into the equivalent of $10,000. So this would be, why would they want to do this? Well, if recent volatility in the foreign exchange rate, if they wait for 30 days time, they're going to be paying a hell of a lot more than if they had to book it today. Obviously the reverse can be true as well, but businesses like certainty, so they'll rather come along and book the deal and lock in the exchange rate, so they know that in 30 days time or 1 month time exactly what they're going to pay for that tractor. So Justin, go ahead. He's now placed a deal for $10,000 US. You can see over here, client bought $10,000 US, sold 140,324 rand. So they now know exactly what the cost of that tractor is going to be in 1 month time. So what we're going to do now, like Justin, we're going to just show you a little bit of behind the scenes of how we build the solution. So this is a conceptual picture of our foreign exchange trading system, showing the various components that make up the system. Starting from the far left, we have various adapters that connect out to exchanges, banks, and ECNs. ECNs are electronic communication networks. Some that you may be familiar with be Bloomberg, Reuters, that sort of thing. That's where we source our market data, or our prices, and where we also execute our trades to hedge off our risk. We then have 6 core trading components. These are functional areas. They're not necessarily map one-to-one to a physical process or application, but they are groupings of where the categories of where the applications would fit in. So at the top we've got our price making capability, which allows us to take a price from several different channels, produce a price of our own, and tailor it for each of our clients that we then send it out to. So the demo that you just saw now would be the web channel down here, but we also distribute our pricing to several other channels, such as back to ECNs. We'll be a price maker on the likes of Bloomberg and Reuters, as well as FIX API, FIX being Financial Information Exchange Protocol. Those are direct connections to other banks and exchanges. Also down here at the bottom you've got retail banking. So if any of you have ever traveled overseas and gone into a branch to exchange your rand for a foreign currency, the behind the scenes those deals would be coming through our trading platform. And then at the bottom, to round it off, there's a series of supporting processes, monitoring MIS, static data, and trader controls, allowing our operational staff to monitor, control our trading environment, and our trading desk to control the prices that they're making out to market. So if we take a look at how that materializes in terms of actual systems or processes, we've got the design pattern that we follow, the architecture that we follow here is all standalone J2SE microservices. Each component is responsible for doing one thing and one thing only. So if we look at from the left, moving from left to right, we've got an example of a market data source being rotors. We've got a ZAR engine, ZAR being the currency code for Rand, which connects to that service, subscribes for market data, or Rand prices in this case, and we receive that on a streaming basis. We'll then convert their protocol into our own internal representation of a price and make it available to our internal components. Throughout the stack, you can see the services are communicating via ActiveMQ. Those are deployed as a network of brokers, which also allows us to run multiple instances of each service and have communication between each of the instances. We've then got a component called an auto pricer. That takes the Rand price that's been received from the exchange and applies a pricing algorithm to the price. Things like trader spread, so that is essentially adding our markup to the price that we've received from one of the market data services, and produces it to a distribution channel, in this case the FX trading service, and that provides things like client tiering. So we may provide the likes of Coca-Cola with a better price than John's PTY trading. That price is then distributed to multiple different channels. Key thing to point out here is in these foreign exchange trading systems, this is our low latency executable streaming prices solution. And when a client executes an order, we have to be able to give a response back to that client within 50 milliseconds, or else the client is going to time out the order and they're going to go look for that trade somewhere else. So in order to be competitive, we have to ensure that our systems are able to respond to the client within 50 milliseconds. You may ask how, or may wonder how is that achievable. Network latency alone between the likes of London and the US can be a round trip can be in the region of 40 to 50 milliseconds alone. So in order to facilitate this kind of trading, co-location is imperative, and I'll get into that in a bit more detail just now. A couple of other key components. You've got a booking service that handles the incoming trades and produces an execution report back to the client. And to close off the loop, we've got a component called ZAR skew, and what that is a feedback mechanism back into our price making algorithms so that we can adjust the price based on trading activity. So if we all of a sudden have a whole bunch of clients buying Rand and selling dollar, we may adjust our pricing so that the pricing going out to clients will affect the clients trading against our platform. This just illustrates a typical deployment of our application stack. So again, this is our low latency pricing solution, or executable streaming pricing solution, and you can see that we deploy an active-active pair of each component. And here it's obvious that we've got the network of ActiveMQ brokers. There's various types of interactions between the components. At the topmost level, we've got the component that maintains the connection with the external venue, called the fix engine, and that translates the fix protocol again into our internal representation of a price and a trade. The interaction between the components, in terms of protocol, is Google Protocol Buffer, and it is over a JMS topic most of the time, unless we require persistence, in which case we use either a persistent topic or a queue. Yeah, and another key thing to point out here is the green lines between the two services. there we're using Hazelcast for clustering and to indicate which particular instance of the service is active at any point in time. What we're showing here is if there's a network failure of any kind between the client and their connector, the client has the option of failing across to their secondary stack. That in some cases that's initiated by the client, or it's initiated by us by controlling where we route the connection from this layer. There's no distribution of sessions or anything like that at this layer. It would require the client to initiate a new session against this particular instance of their application, but it happens very quickly, and it's within a couple of seconds they're up and connected again. What's important to show here is that if a particular component fails during the day or during the trading day, we have the ability of failing across to at any point in the stack to a service running in the other stack. What this also facilitates is us deploying new versions of the application intraday, which means no less late nights and no weekends. So that's good. And then again, if one of the ActiveMQ brokers were to fail, we have the ability of going back across the stacks at any layer in the architecture. One of the downsides of this may be that there's additional latency through the system. That's why we make a conscious decision around where these two stacks are hosted, and the connectivity between the data centers that host them is minimal latency. So I've mentioned some of these things already, but just to have a look at the technology stack that we use. Majority of our services are running on Red Hat Linux. In the bottom left there, Java, obviously central to all our components, all written in Java, J2SE. In terms of monitoring, question of monitoring was raised earlier. We're using a proprietary product there called ITRS Genius. Deploy a probe onto each of the servers, and it allows you to monitor a series of processes running on that box. Facilitates JMX connections to the components if you want to expose operations to or functionality to the operations team. ActiveMQ, that's obviously key as our messaging middleware between components. And then up front, the eMarket Trader demo that you saw, that's using software that was provided by, or that we purchased from Kaplan, but obviously a lot of integration work surrounding that. We do have an element of J2EE in our world. You can see IBM WebSphere there. That's obviously being a corporate. There are points where we have to integrate with other areas of the bank, and that's where that solution is used. And then F5 and Sybase F5 is where we use that for our application delivery of several places. Look at the development tools that we use. Jenkins and Nexus as part of our CI and artifact repository. Every check-in on all those components that you saw there would result in an automated build with unit testing and acceptance testing. We do have an element of continuous delivery where the components that are built are deployed to a test environment, and performance testing is run against those deployed applications, and we're able to look at the metrics that result from it. It's ongoing journey, the continuous delivery, and like we saw earlier, obviously our aspiration there is to be able to make a decision to deploy to a production environment based on the results of the functional and performance testing that's done in a test environment. We're not quite there yet, but we're moving closer and closer to that. Source control, primarily Git and Subversion, SonarQube for static code analysis, and Confluence for knowledge management and wiki pages. There's also Rally software up there. We're a distributed team. We've got a presence in London, Johannesburg, and Cape Town. So the teams that are working remotely leverage Rally Dev significantly for logging stories and just giving feedback on progress. This is a view of our data centers here in South Africa, Samrand being our primary data center and River Club being our secondary data center. The key thing to note here is the distance between the data centers. Obviously, where latency is a concern, you need to make a conscious decision around where you deploy applications. However, all the that executable streaming prices solution and eMarket trader solution are all hosted in London, and that's spread between Equinix, LD4, and Global Switch. The reason for that is those are hotspot data centers in terms of where the big market participants play, and it allows us to co-locate with them and cut down latency to an absolute minimum. It's also got close proximity to the London Stock Exchange and other key market data sources around London. As I said, we have a presence in Joburg, three different offices. Primarily, our development team is based in Constantia Valley, and our business is located at Rosebank. The head office is obviously in Joburg, Joburg CBD. Cape Town office, that's where I'm based, and London office, we've got a team of developers sitting over there as well. Project methodology, all lean agile principles. You can see here we've got a team that's chosen to use a physical Scrum board to track their progress. Other teams using Rally Dev, but the same principles apply. Bottom left, you've got a standard issue workstation surrounded by as many monitors as you can fit on the desk. This is a closer look at the Rosebank office. That bottom left is our trading floor, and that's where most of our users operate from. Very innovative environment, desks that move up and down, segregated networks, workstations that follow you around wherever you log in from. So a look at some of the technology that's gone into the Rosebank office. And the right-hand side is the Dell PowerEdge blades, and those host the traders' workstations. So whichever terminal they go to, they can log in, and they'll have exactly the same setup that they'll have from anywhere else. And that pretty much covers it. Happy to take any questions. Yes.
I'm just asking, what web technology or what web framework do you use for this?
Well, it's quite easy. It's all HTML5 JavaScript based. We use Kaplan for sort of foundations that provide various libraries that we incorporate, and then we build on top of those. So that's pretty much what we use. Then that's purely for the front end. As mentioned, for streaming, we use a product called Liberator, which is a streaming comment server that provides sort of WebSockets, non-polling, typical polling as a fallback mechanism. Then in the back end, we use J2SE microservices that's to integrate with other systems such as Red.
Yep. Anyone else? Yes.
Why the choice of ActiveMQ versus other queuing applications like RabbitMQ?
eMarkets is a fairly new initiative in the bank. We've recently, I think, celebrated our 4th anniversary. When we first set out on this, we did evaluate several different products, but the decision was made at that point based on maturity of the various solutions and performance testing that we had done to go with ActiveMQ. Yeah.
Has ActiveMQ ever failed for you guys, and what's the failover when ActiveMQ decides to just fall down?
Yes, surprisingly it's been a very rare occurrence. I think we've had one major incident that happened to be a known bug. That's the primary reason that we like the use of open source software. You immediately turn to the community and you find that it's happened to 10 other people, and they've give you a pretty good idea of how to prevent it going forward. But we do stress test the systems significantly before we put it into production environment and ensure that the failover mechanism is sufficient for us. So I think in the last 4 years we've probably only had one incident that's burnt us with ActiveMQ.
What's the failover mechanism? Yeah, for ActiveMQ.
It's a network of brokers. So there's we've got it in a master-slave configuration. So if one node fails, the other node takes over. There's a Hazel cluster between each microservice. So you saw FX trading service, for example, that would be clustered in a Hazelcast cluster. We don't. There's only the only thing that we leverage from the cluster is the primary secondary instance. So to know which one is active and which one is in secondary mode, and we also use it for lightweight distributed caching. So there are some things that both services need to know about, and in that case we publish it over the Hazelcast cluster.
Don't you need an odd number of machines in the Hazelcast cluster in order to guarantee that if one goes down, you'll still have a quorum to agree on the values in the data set?
We aren't persisting any data in that cache, so there's no need to guarantee that we've persisted something to disk. It's purely to know which instance is in primary mode, which is in secondary mode, and also to share. For example, if a quote is made over one instance of the forex trading service, it needs to be available on the other instance, so that when an incoming order is validated, it can be validated against the same price that was made over the secondary instance. So it's there's no need to have an odd number in our architecture.
Any other questions? Yeah. Thanks very much, Ross.
Cool.
Cheers.
Thanks, guys.